Hello, it's Mrs. Butcher here, and this video is about nth roots and rational exponents. Alright, so let's define nth roots. You guys all know that 2 squared is 4. So that means that 2 is the square root of 4. And you know that 2 cubed is 8. So we say that 2 is the cube root of 8. So basically for any numbers, if we said b to the nth power equals a, then we would say that b is the nth root of a. Right? Like if we took the nth root of a, we would get b. If we took the cubed root of 8, we would get 2. And if we took the square root of 4, we would get 2. Alright, roots are written in this form. We have a little number, n, and then we have the radical symbol, and then we have the a. So the nth root of a, like that. When we do a square root, we don't put the little 2, it's just understood to be there. But that little number right there is called the index. Index. And then the number inside the little house, the a, it's called the radicand. But here's something new for you. Roots can also be written as rational exponents. Rational, like fraction. So we could say if I said a squared, if I were to raise that to the 1/2 power, think about your power of a powered property. That's the same thing as saying a to the 2 times a half, which would be a to the 1 power, which is just a. So the opposite of squaring is raising something to the 1/2 power. So if I said a squared and I took the square root, that's the same thing. I would get a, right? So taking the square root of a is the same thing as taking a and raising it to the 1/2 power. All you have to do is think about the little index right here is this number underneath. The denominator of your rational exponent is your index. So that also works if I were to say a to the 3rd power. If I were to take the cube root of a to the 3rd power, I would get a. If I were to take a to the 3rd power and raise it to the 1/3, then that would be 3 times a third, which is a to the 1, I would get a. So a to the 1/3 is the same thing as the cube root of a. And a to the 1/4 would then be the same thing as the 4th root of a, and so on and so forth. So for our nth root of a, which is the same thing as a to the 1 over n power, if n is even, if we're taking even roots, square roots, 4th roots, 6th roots, then we can't take the even roots of negative numbers. So if n is even and a is negative, we will not have any real roots. And we're not going to play with imaginaries here, so don't worry about that. We're just going to have no real roots. But if n is odd and a is negative, we can have real roots. We'll actually have 1, because you can take like the cubed root of -8. That's going to be -2 times -2 times -2. The cubed root of -8 is -2. That can happen. So if a is negative and we have an odd root, we will have 1 real root. Alright, if a is 0 and we're taking the even root of 0, it doesn't matter if I take actually the even root or the odd root of 0, I'm only going to have 1 answer. The cubed root of 0 is 0, the square root of 0 is 0, the 280,000th root of 0 is still 0. And if a is a positive number, when I take the square root or any even root of a positive number, I can actually get 2 answers. Because, as we've been doing all along, if I take the square root of something, I get plus or minus. But if I have an odd root, any odd roots, cube roots, 5th roots, we're not going to have plus or minus. Because for the odd, the minus is a minus, and the plus is a plus, and they're separate. So just remember, if your n is an odd number, and you're taking the odd root of a positive value, of a positive a, you will still only have 1 real positive root. Alright, so just as a review, we said a to the 1 over nth power is the same thing as the nth root of a. So what happens if we take a number and we raise it to m over n? That's the same thing as taking the nth root of a to the mth power, or the nth root of a to the m. It doesn't matter if you take the power before or after you do the root. It doesn't matter. Oh, dog, quit barking. So yeah, there's Lola. She's barking at you. She's trying to help me teach you math. Alright, let's think about if I had a to the negative 1 over nth power. All that means is the 1 over n thing gives you the nth root of a. The negative exponent means that we're going to take the reciprocal of that. So we're taking 1 over the nth root of a. So they're two separate things. If I had a to the negative m over n, then that means that the negative gives us the reciprocal, and then we would be doing the nth root of a to the m. Inside or outside, it doesn't matter. And of course, this is only when a is not 0, because we can't divide by 0. By the way, my little dog, her name is Lola, and I might ask you about that later, so I'm just giving you fair warning now. And here's some example problems. Let's solve x to the 5th equals negative 32. So now we know that that means x equals the 5th root of negative 32. We can take the odd root of a negative number. The 5th root of 32, we have to think, okay, what do we raise to the 5th power that will give us 32? And since you're supposed to memorize all these powers now, you'd know that that's 2. 2 to the 5th is 32, but we want negative 32. Well, if I raised a negative 2 in parentheses to the 5th, that's the same thing as saying negative 2 times negative 2 5 times. And so these would make a positive, and these would make a positive, and that would be a negative, and then that would make a positive, and that would be a negative. So our final answer would be a negative. So actually, the 5th root of negative 32 is negative 2. Negative 2 raised to the 5th power is 32. Alright, next one. X to the 4th equals 81. So that means that we are taking the 4th root of 81. We want to know, what would we raise to the 4th power? What would we multiply by itself 4 times to get 81? And since you've memorized all your powers, you know that that's 3. 3 to the 4th is 81. So we know that 3 is the 4th root of 81, and x is 3. But if I were to multiply negative 3 4 times, then the negatives would all cancel out, and I'd still get positive 81. So x equals 3, it also equals negative 3, or you can say plus or minus, as long as you write it nice and clear, plus or minus 3. So for this last one, it says x to the 4th equals negative 81. X is the 4th root of negative 81. What can I multiply by itself 4 times and get a negative 81? Well, you can't, because any time you multiply something by itself, you're always going to get a positive. So we cannot take the 4th root of negative 81. There's no solution, no real solution. Alright, so now we're going to simplify. And remember, when you're simplifying, that's different from solving. Solving, you will include your plus or minus, but when you're simplifying, there's no plus or minus. You're just simplifying. If I gave it to you as positive, it's positive. If I gave it to you as negative, it's negative. So 25 to the 1/2 power, that's the same thing as taking the square root of 25, and hopefully you guys all know that that is 5. It's not plus or minus because I didn't say negative. I just said positive 25 to the positive 1/2 power. Alright, so 16 to the 3/2 power. That's the same thing as taking the square root of 16 cubed. You have a choice of cubing before or after you take the square root, so just use some common sense. If I cube 16, I'm going to get a really, really big number. And then I can take the square root of that really, really big number, but chances are I don't have it memorized. However, I do have the square root of 16 memorized. That's 4. And I do have 4 cubed memorized, and that is 64. Alright, look at the next one. 81 to the 3/4 power. So that's the same thing as taking the 4th root of 81 to the 3rd. You could cube 81 first and then take the 4th root of that, but that just sounds horrible to me. Or you could take the 4th root of 81, which we all know is 3, and then cube it, and 3 cubed is 27. Alright, look at the next one. 9 to the negative 1/2 power. Remember, when the exponent is negative, we're taking the reciprocal of 9 to the positive 1/2 power. And so we're taking 1 over the square root of 9, so we're taking 1 over 3, or 1/3. Now, if I say negative 9 and I have it in parentheses to the 1/2 power, see how that's completely different from this one? If it's in parentheses, then I am trying to take the square root of negative 9. And since I said we're not playing in the imaginary land, this is actually going to be no real solution, or empty set like that. Or you could say 3i if you wanted to. However, if I have the negative 9 to the 1/2 power and I don't have parentheses, then that means I'm saying negative 9 to the 1/2 power. So I'm saying negative square root of 9, which is negative 3. So you guys see there's a very important difference between this one and this one. All right? So finally, we're going to solve some more complicated ones, like 3x squared equals 108. First thing you need to do is divide both sides by 3. 108 divided by 3 is 36. And no, you won't have calculators for this test that we're going to take over this, so you do need to strengthen your division and multiplication skills if you need to. Alright, so then we'll say, alright, x is the square root of 36, which we know is 6, or negative 6, because we're solving. It is plus or minus 6. There are two answers, two x values that would work for this one. Alright, the next one, x cubed plus 40 equals 13. First thing we have to do is subtract 40 from both sides. 13 minus 40 is negative 27. So now we want to take the cubed root of negative 27, and that is allowed. You can do that with odd roots, because negative 3 to the 3rd power is negative 27, but not positive 3 to the 3rd power, so x is negative 3 only. Alright, two more. 4x cubed minus 120 equals 200. First thing you're going to do is add 120 to both sides. So we have 4x cubed equals 320. Then we're going to divide both sides by 4. We get x cubed equals 80. And then we're going to take the cubed root of both sides. X equals the cubed root of 80. And since you've got your powers all memorized, you know that there's not a cube root of 80. So you think, alright, well, what perfect cube goes into 80? 8 does. That's 8 times 10. So I know the cubed root of 8. The cubed root of 8 is 2. And then the cubed root of 10 we can't take, so x equals 2 cube roots of 10. And that's the way you would write the answer. 2 cube roots of 10. Alright, and then this last one, x plus 5 to the 4th equals 16. Now, some of you are going to be tempted to FOIL this out 4 times, because that's what we did in one of the last chapters. But don't do that. We're solving for x, so we're trying to make this smaller, not bigger. We want to take the 4th root of both sides. So we want to say x plus 5 equals the 4th root of 16. And since you've memorized that, you know that the 4th root of 16 is 2 and negative 2. So I have to take away 5 from 2 and negative 2. X equals 2 minus 5 and negative 2 minus 5. 2 minus 5 is negative 3. Negative 2 minus 5 is negative 7. And you can check for extraneous solutions just to plug them back in and make sure. Negative 3 plus 5 is 2, and 2 to the 4th is 16. Negative 7 plus 5 is negative 2, and negative 2 to the 4th is positive 16. So they both work. X is negative 3 and negative 7. And that is the end of our Nth Roots and Rational Exponents notes. Thanks, guys.